Hi guys, this is Prompt Engineer. In this video, we are going to continue our podcast on MOJO Programming Language that we started a couple of days ago. Now, MOJO is a new programming language for all the AI developers. If you don't have access to the MOJO playground, you can request for the playground and you would get a message or a mail like this. So let's start up the playground. This is the playground. We have been looking at the different components of this programming language, and in this video we are going to look at the CopyInit and the moveinit special methods. In the context of MOJO, that's the programming language that we are talking about, it supports full value semantics, which means that objects or instances of classes can be treated as values. This concept is similar to how values are handled in languages like C++ and Swift. To facilitate the definition of simple aggregates of fields, MOJO provides the add_value decorator. This decorator simplifies the process of defining such aggregates by automatically generating the necessary methods and boilerplate code. However, MOJO also caters to advanced use cases where more customization is required. It allows developers to define custom constructors, destructors, and copy move constructors using special methods provided by Python, such as init, del, copyinit, and moveinit. These low-level customization hooks are particularly useful in low-level system programming scenarios where manual memory management might be necessary. For instance, let's consider the example of a heap array type in MOJO. When an instance of this type is constructed, it needs to allocate memory for the data it will hold, and when the instance is destroyed, it needs to deallocate that memory. By using custom constructors and destructors in MOJO, you can define the behavior to allocate and deallocate memory appropriately. The init method can be used as a custom constructor to allocate memory when the object is created, while the delete method can serve as a custom destructor to release the memory when the object is destroyed. In addition, MOJO introduces new special methods called CopyInit and moveinit to enable custom copy and move constructors, respectively. These methods allow you to define how the object should be initialized when it is copied or moved, which can be essential when dealing with manual memory management or other low-level operations. Overall, MOJO's support for value semantics and customization through special methods provides flexibility for developers working on advanced use cases, especially in low-level system programming scenarios that require manual memory management. Let's look at this code. These lines import the pointer class from a module called pointer. These modules provide functionality for working with pointers and printing without a new line, respectively. This line declares a new struct called HeapArray. These lines define three variables within the HeapArray struct: data, size, and cap. Data is of type pointer init, which suggests it is a pointer to an array of integers. Size and cap are both of type integer and represents the current size and capacity of the array respectively. Now this is a constructor init function for the heap array struct. It initializes the cap variable to size 16, size to 0, and allocates memory for the data array using the pointer allocate method, which suggests it allocates memory for an array of 16 integers given by the self.cap value here. This is another constructor for the heap array struct, which takes in two arguments, size and val. Both are of integer type. It initializes cap to size into 2. It initializes size to provide a size argument and allocates memory for the data using the pointer allocate method. It then uses a loop to store the value or val in each element of the data array. This is the constructor delete for the heap array struct. It is responsible for freeing the memory allocated for the data array using the pointer.free method. This is a method called dump that prints the elements of the data array. It uses the print no line function to print the opening bracket without a new line. Then it iterates over a range of self.sizes and print each element of the data array using the self.data.loadi call. If I is greater than 0, it prints a comma and a space before printing each element. Finally, it prints the closing bracket without a new line. Overall, this code defines a heap array struct with constructors, a destructor, and a method for printing the array elements. The struct manages memory using pointers and provides functionality for creating and manipulating dynamic arrays. Here is an example. This code demonstrates the usage of the heap array, struct, and the constructors, destructors, and a dump method. Here, a new heap array instance named A is created using the constructor that takes two arguments, 3 for the size and 1 for the value. This will create an array of size 3 with all elements initialized to 1. The dump method is then called on A and prints the contents of the array as 111. This code is commented out, but it attempts to assign A to a new variable B. However, it triggers an error if we run this code because the heap array struct doesn't implement the CopyInit method, which is necessary for performing the copy initialization. Therefore, attempting to directly assign A to B will result in this error. Now again, we start a new instance of heap array named B using the constructor that takes 4 as a size and 2 as the value. This creates an array of size 4 with all elements initialized to 2. The dump method is then called on B, which prints the contents of the array as 2222. Finally, the dump method is called on to see the A again, and you can see that the 111 is printed for A. In this case of heap array, if we still want to use the copying or enable copying, we would need to implement the CopyInit special methods to copy the contents of A into B. Now in this code, we have implemented the CopyInit special methods for the heap struct. This method enables copying of instances by copying how the data should be copied from the original instance other to the new instance self. So the CopyInits take two arguments, self, which is the instance being copied into, and other, the instance being copied from. The in-out modifier indicates that the self instance can be modified during the copy process. The cap and size variables of the new instance self are assigned the values from the corresponding values of the original instance other. A new pointer int object is created for the data variable of the new instance, indicating the allocation of memory for the array. The self.cap value is used to determine the allocation of the allocated memory. A loop is used to copy each element of the data array from the original instance to the new instance. The store method of pointinit is used to store the value from the other.data.loadi into the corresponding index of self.data. With this implementation, you can attempt to copy an instance of heap array. The CopyInit method will be called to handle the copying process by initializing the new instance with the appropriate values from the original instance. Now let's look at this example now. If we look at this code, here heap array is initialized, an instance of heap array is initialized as A. A is dumped, which means the contents of the A are printed out. Here we declare B is equal to A, and then we see that if we print B and A, we see the copies of the contents of A has been copied to the contents of B in B. Now MOJO provides full control over the lifeline of the values, including the ability to make types copyable, move only, and non-movable. And this is more control than languages like Swift and Rust. Also, we can implement the moveinit method in the similar fashion. Now, having said that, this brings to the end of this video. As always, like, share this video if you liked it. Subscribe to my channel for more content like this. Check out other videos on my channel. So that's it. Have a nice day. Bye-bye.